Okay, so our K value came out to be n pi over a. And we have supposed our K equals 2me square root over h bar. Now I can put this value here, and this will be equals to n pi over a. If I square both sides, then 2me over h bar square is equal n square pi square by a square. And from here I can write that energy E is equal to n square pi square h bar square divided by 2m a squared. Now I know here that n is having the values 1, 2, 3 and so on. So when n is equal to 1, then E will have some value. When n is equal to 2, E will have some value. So this thing I can write a subscript in here as well. When I write the subscript n, it means when it will be E1, then it will be 1. And E1 will be pi square h bar square over 2m a square. Similarly, E2 will be 4 times this thing, and E3 will be 9 times this value. So this is the first available energy, which you call the ground state energy. This is the ground state energy. But this is giving some critical information. The one information is that the energy levels now are discrete, because this n can have value 1 or 2 or 3, not 1.1 or value 1.01 and so on. So there are very distinct levels which exist. In between, the particle will not exist. That energy is not there. That level is not there. The other thing which happened here is that the energy, the ground state energy that came out, means when the particle will not be influenced by anything. The particle will not remain stationary inside a box. It will not be static. It will not be still. It will always be in motion. And this will be the energy of this one. This is the minimum possible energy. The energy is not zero. When E is 0, it means the particle is stationary. When its lowest energy is this much, which is having some value, then it means the particle will be no more stationary. Our classical particle was stationary inside a box, and we were able to say that this is the particle, and it is existing here, here or here. But our quantum mechanical particle will be no more stationary. It will have some ground state energy. Ground state energy means the energy which it will possess without any external agent. And this is a quantum mechanical effect. There is no ground state energy of a classical particle. Classical particle ground state energy is 0, right? While quantum mechanical particle ground state energy is this much. Any energy above this one, like the next energy will come 4 times this one, will be the excited state energy. Okay, so as we are done with this, now here we will come back to our equation, and our equation was that sine of x is equal to A sine kx. This was our wave function because B was equal to 0 according to geometry. Now what is the value of this A? We will determine this by the normalization procedure. So I can write that from minus infinity to plus infinity, sine mod square dx is equal to 1. Always for a quantum mechanical particle, you know the normalization condition. This is the probability of the particle. Sine mod square is the probability density multiplied with dx is the probability will be always equal to 1. And now this thing I can write that according to our geometry, this equation will turn from not from minus infinity but from 0 to A. Because our particle is existing from 0 to A, and sine square will become, as there is no iota inward, so we can simply square it. A square sine square kx dx is equal to 1. You know how to solve this equation. You can write this equation as 1 minus cos square x, and then you can apply the conditions, the limits, the 0 to A limits, and you will come to know that A comes out to be 2 over A square root. This normalization constant you will have to determine that this comes out to be 2 over A. And now you are having your wave function sine of x equals 2 over A and sine kx. And if I want to put the value of k here, because we have determined the value of k, which is equal to n pi over A, then sine of x is equal to 2 over A and sine of n pi over Ax. And this comes out to be the state of the particle, the equation of the particle. Now this equation has all the information about our particle in a box under those conditions. Clear? So this is state of the particle. Now if you look here, we are having sine n pi x over A. So this n will have values 1, 2, 3 and so on. So when it will be n equal to 1, it will be the ground state wave function. It will be the ground state of the particle. Then I put here the index n as well. That will be psi 1. Clear? Similarly, psi 2, it will be the excited state of the particle, n pi over A. So our particle is now in this equation, and let me write these solutions. So the solutions are, now what are the solutions? They are sine of nx is equal to 2 over A and sine n pi over Ax. This is a very interesting solution. And now put this n equals 1, then this implies that psi 1 of x is equal. What it will be? It will become 2 over A sine pi over Ax. 2 over A sine, and it is equal to 1, so pi over A and x. Clear? Now, why not to plot this equation, and this was actually our box or our potential well. This is 0 and this is A, and over here we are having infinite potential. Here we are having x in this direction, v equal to 0. Now this point is having, you can say on this axis we are having the width of our potential well. On this side we are having the potential, such that the potential is infinite on the walls. Now what about, I want to plot my psi1 of x. So I will write like this, that what's the value of psi1 at x equal to 0 first. At this point, what will be psi1? And I come to know that x is equal to 0, so psi 0 is 0 and my wave function become 0. What about the value of at x equal to a? When x is equal to a means on this wall. Earlier it was this wall, now it is this wall. So at x equal to a, these two will cancel, sine phi is equal to 0. So I got that my wave function on this wall and here is equal to 0. Now let's find out the value at central point here. What this central point is? This central point is actually a over 2. So find the value of psi1 at x equals a over 2. Then what is this? This is equal to 2 over a and sine. When x is equal to a over 2, so a will cancel and sine pi by 2 is equal to 1. So this is pi by 2 and this value is 2 over a square root, 2 over a square root. So if this value, if I write here, now on this side I am plotting x and on this side I will now plot psi n of x. Right? That what is the value of psi n of x? At this point our value is equal to 0. At this point our value is equal to 0. Let's say this is the value that we have 2 over a value here. So our wave function, our particle is having this value. If I find some more values, then I come to know that this is something like this. Clear? If you find more values in this one, then on these points we are having 0 wave function, and on this point the value of wave function is 2 over a. If I go beyond x a over 2, then I see that the sine value is decreasing. If I go here beyond 0, I see that the sine value is increasing and I will have this half wavelength here. Clear? Similarly, you can write that what about psi of 2x, and this will be equal to 2 over a and sine and n pi, so n will become 2 pi over ax. It will be this situation. Now these things will remain the same, like sine of x equal to 0 and equals to sine of x equals a. These will come out to be 0. You see here, when x is equal to 0, then this whole becomes 0, sine 0 is 0, sine 2 is equal to 0. when x becomes equal to a, then a will cancel and sin 2 pi is equal to 0.